In this episode, we address a few common misconceptions from the Math Moment Maker community, in particular around teaching with problem-based math lessons.
Yeah, stick around and you will hear how to find the right balance between what students know and what they need to learn in your lesson, when we should be assessing for learning versus of learning or as learning, how to consolidate a problem-based lesson, and how to manage the flow of the class when some students complete work quicker than others. Kyle, let's do this.
Here we go. Welcome to the Making Math Moments That Matter podcast. I'm Kyle Pierce.
And I'm John Orr. And we are two math teachers who together,
with you, the community of math moment makers worldwide who want to build and deliver problem-based math lessons that spark curiosity,
fuel sense making,
and ignite your teacher moves. Everybody, we are super excited to be able to just have sort of this duo episode, John and I, to dive into a common misconception. Not only do we receive emails from people through the website, people listening to the podcast, but some of the friends that are in our online workshops and in the academy, and even some of our colleagues when we're chatting about trying to use more problem-based approaches to learning math. And we want to get to the bottom of it, right, John?
Yeah, totally. Yeah, we do get those regular emails to say like, hey, I'm working with this topic. How do I address this? I'm working with this thing. Or this is the way my lesson went. Would you guys have any suggestions? We get those all the time. And also, if you're an avid listener of the podcast, if this is the 7th episode you listen to, the 10th, maybe you've listened to all of them. We know there's a couple of you out there, but we have Math Moment Maker or Math Moment Mentoring Moments episodes where we chat with people, and a common misconception that comes up. We got a couple to talk about here, the common misconceptions. One, Kyle, being what is I think people miss the purpose of teaching with a problem-based lesson, and in a problem-based lesson meaning the type of lessons that we've been talking about here on this podcast for the last few years of teaching through problems and instead of teaching skills first and then those application or those tough problems later. We've been talking about teaching through problems that are very curious and very low floor, high ceiling type problems. So I think one misconception that we're going to talk about here in this episode is what is the real purpose to teaching that? I think there's a little bit of misconception around that purpose and the goal. The second one is, I think, Kyle, we get lots of, not lots, but we get teachers that think, hey, I did this lesson and I think it was a failure. And then they explain to us why that's the failure. And then we usually go no, that wasn't a failure. So there's a misconception around, again, what is happening, why they think their lessons are a failure. So we're going to talk about that. And then we're going to talk about where these lessons fit into the flow of things, and whether where do we put a problem-based lesson and what's the best place for that. So we'll talk about those 3 things here in this session. Kyle, let's go.
All right, here we go. So John, starting right from the top. So you've highlighted sort of 3 of these sort of misconceptions. Some people might even argue a lot of times they're very closely linked. And I would argue that oftentimes one of these misconceptions can kind of spiral into some of the others. Right. So let's start right from the top. And it's sort of rethinking, or maybe it's the first time you're thinking about this, but thinking and reflecting on what is the purpose of a problem-based lesson. If you pause for a moment and think to yourself, why are you trying to do this work? And I don't know about you, John, but I think many people, not everyone, I know for me, I can say this was true when I started this journey. I was looking to engage students. Right. But for me, that was it. I was sort of they're not really paying attention. Or I know when I say they, I'm talking about a good chunk of my class, right? You have this group of students who, they're going to do whatever it is that you say, just because, that's just who they are as students. And, they want to get their stuff done and so on and so forth. But even just looking at the expression on their face, oftentimes they're not maybe enjoying the process.
Yeah.
So we were looking for engagement, right?
Right. Exactly.
And I would argue that problem-based lessons can help you do that. But oftentimes, you know, things sort of like kind of fall apart a little bit if that's our only intent for a problem-based lesson. And I can say pretty confidently that both John and I, our purpose of building a problem-based lesson now is a lot different than back when we first began. You know, like we used to think that,
like me.
Yeah. Like, you know, a lot of times people like confuse their goal as being to see if students could do what we've already taught them. So, you know, like
the tough problem. Yeah. Like
right,
it was like,
right.
It's like yesterday I introduced, you know, solving equations using, you know, two-step solving equations. And I showed how to balance, you know, do the balance method. Or maybe you said, you know, we subtract this on this side. You showed them opposite operations, you know, however you taught
like
it.
The formula, you know, whatever the formula is.
You went through some examples. Right. And this is the way I used to do it. And then either you saved this problem that you're like, I got a good, tough challenge problem for them. Right. And it was like, or when you first got into it, you're like, I got this engaging kind of like this very curious, engaging problem. I'll see how they do on it tomorrow. Right. So I taught them all these skills today, and I'm going to use that tomorrow and see if they can step up or rise to the challenge, and see if they can piece together and apply their learning to solve that particular curious problem. Maybe it started with a video, maybe it didn't, maybe it just had this curious low floor entry point and it did have a high ceiling, but we're going to leave it to the next day and not start on that day. Because I definitely did that, Kyle. I started teaching problems that way, using them as like these engagement pieces, but only after I taught everything up front.
Yeah, absolutely. And, you know, for us now, like we look at it actually quite differently. And, you know, I was co-planning with a teacher in my district recently. And, you know, this teacher is like super eager to bring in problem-based lessons into her curriculum. And that's fantastic. That's awesome. And I'm going to say naturally, because, you know, for me, it was naturally, this is how I did it. I know, John, you did the same, was like, I looked at what I was already doing. So I kind of looked at, you know, how I had my course structured, you know, my program. And then I would just drop these problems in. Right. And typically, like you said, I would drop them in like after, you know, like after I did some teaching, because remember, like the kids haven't been taught how to do it yet. So that was my thought. That was my, you know, thinking. And again, you're not wrong for thinking this if you're going, well, isn't this what we're supposed to do? And over time, what we realized was, like, okay, maybe the problem was a little more engaging. But the reality is like, I still got a lot of the same that I would have gotten regardless of what problem I gave those students. And what I mean by that is, you know, if let's say I was teaching circumference of a circle, or maybe the area of a circle, or, you know, whatever, circle measurement. And, you know, I like teach them the formula for circumference, and, you know, I teach them what pi is. And even back then, I'll be honest and say, like, I said what pi was, but I didn't like let them experience what pi was. And then I give them like the area formula. And then I would give them a problem like my cookie cutter problem that I had done over 10 years ago. I think it was when I did cookie cutter. It was to drop in to my unit for circle measurement. I was like, all right, they're ready for it now. And I would drop that problem in, and sure, they were, you know, engaged in the notice and wonder. You know, we didn't have the curiosity path kind of mapped out for ourselves yet. So, you know, I'm sure it could have been way better than what we were doing at the time, but it was an improvement for my class. And then what I would get though was a lot of the same. Like I'd get the same students who could do the problem as before I did this type of lesson, and the same students who like weren't really willing to kind of like take a chance or take a risk. And, you know, what we realized later was, you know, by doing this, it's like students know that they're supposed to know what to do. So if they don't if they don't know what the next step is, they're like, I'm going to just opt out, and I'm going to wait for like, you know, Sandy over there to do it. Cause like, I know she'll know what to do, but I don't know what to do. And I should know what to do by now. Right.
You bring up a really great point, because I've experienced this this totally when you regularly don't engage your students in that thinking process first, and they're left to be like, I'm supposed to follow along in this kind of process. And if I don't know how to, like, if I've not experienced kind of diving into a problem and not knowing how to do it, they will hold back and wait for the kids who have, may have participated more often in class to solve it first, then diving in. I've definitely experienced that in my class when I pre-teach things.
Yeah, absolutely. So it was kind of like, when you zoomed out, it was like, okay, I felt like I was doing a lot more work, because it was like I was trying to teach two different styles of like teaching. And it was like, almost like the kids were like, which one are we doing here? Are we doing this or doing that? And I got a lot of students who would just be like, can you just tell us like the formula, right? Like we'd get a lot of those things. And, what we realized was, this is actually the goal for us is not to test students on whether they could apply what I already taught or not. It's actually looking at it from this opportunity to introduce students to new learning. So, it was almost like we weren't doing problem-based lessons. We were actually doing we were doing like contextual practice, right? Like we were doing curious practice.
Yeah.
Which,
you were applying.
Bad. I mean,
you were applying learning, which you had taught. And that's part of the work that we have to do, is that we do have to apply our learning in different situations. But for us, right, Kyle, for us, the purpose of the problem-based lesson for us isn't that, can I apply the memorization tools I've already put in place on a new situation. For us, we want to engage our students in a new situation that they don't know how to, solve right off the bat. And we want to, get them thinking and see strategies that we can emerge to get towards a learning goal.
And you again, being very, I just want to be very clear on what John just said. Like, we still need the problem to be accessible, but maybe not with this new tool that we're hoping, or this new strategy, or this new thinking that we're hoping to emerge. So it's kind of like thinking about it different. Like, okay, I don't want to use a curious real world. I'm using little bunny ears for those on YouTube watching, like real world or 3-act math or whatever the type of problem that you're using. It's not for practice. It's actually to introduce new learning. It's actually to introduce students for the opportunity to think,
right,
and to almost like prime their brains for this new learning that we're going to do. And John, I think that's kind of like, we're going to continue this conversation, but I think it's a nice segue into what we were going to talk about, where we get a lot of teachers that, come back to us and they say, I tried this lesson over here. Like someone recently told us, like the woolly worm race is what they tried. And they were like, and I think it was a total failure. And then we went on to read it, and you and I were sort of like, actually, no, that doesn't sound like a failure at all, right?
Yeah. Yeah. And when we get an email like that, or we talk to another teacher like that, I think what's happening, and this is that misconception piece, is that the teacher has missed the idea of a particular goal that can be great, and I think if you're using your problem-based lesson to practice, that's a different goal. That's like that. I think people can do that, but I think there's a much deeper and richer experience for you and your class if you do use it at the beginning of, say, a topic to emerge ideas and bring about those ideas. And I think this teacher that was emailing us actually was doing that, Kyle. They were not using this task to practice and hoping that the kids got it. They were and they think it's a failure there. They're going, okay, I'm all board. I'm on board, guys. I want to use a problem-based lesson to introduce an idea with my students. But I think the misconception when they thought it was a failure was thinking the idea that even though I haven't taught this skill, pre-taught it, they think, if by just using this problem-based lesson, kids will naturally show me that skill. And I think there's a misconception right there. It's not all of a sudden my kids are going to be solving 2-step equations just because I'm using this task. Or my kids aren't going to be able, my kids aren't applying, or building a linear equation because it's a linear relation, not a nonlinear relation, just because I'm using this engaging task. There's a lot more nuance that has to happen on the teacher's end to bring about those. And I think that's why the teacher, thought it was a failure, because they expected all of a sudden to use this task and kids to all of a sudden show these skills and go, hey, look, I just taught this lesson. I got my learning goal out, but wait, the kids didn't do it. So it's a failure.
Yeah, totally. And in particular, this particular email was saying like, a group of students were good at, and with Woolly Worm, for those who haven't tried that unit, it's about representing and comparing fractions. We're using essentially like a linear model, but it's more of like a bar or a tape diagram that we're kind of getting towards this linear model. And, some of the students were unable to represent some of the fractions, which then obviously hindered their ability to compare the fractions. Like the big idea for this unit is all about representing fractions and comparing fractions. And some of the students were unable to do that. And this is where we've mentioned this before on the podcast, but I think it can be missed very easily, is that we want to use these problem-based lessons as like assessment machines, but not necessarily like summative assessment machines, or even like, I would say formative assessment. Yes, but almost more diagnostic in a way, because if you think about it, it's like, okay, I'm introducing this idea of representing and comparing fractions with my students. The reality is that students unless you're teaching kindergarten, it's likely that students have had to represent and compare fractions in some way, shape, or form. Whether they were proficient with it or not is another story, but it's not like brand new out of the bag. Like they likely know, hey, like this is what a fraction is, and we can explore fractions. But now this teacher basically did this problem-based lesson, something that all the students can access. And then by the time they were ready to enter into the consolidation of the lesson, they knew so much about their students and where they were, which is essentially the goal. Because now we walk into the consolidation going, all right, this is what we're going to talk about in the consolidation based on what I saw from this group or that group or this, this student or that student. You actually get to look at that and go, here is what we are going to dig into today in order to take our next step. It wasn't supposed to just magically happen on its own. Of course, as you're going around the room, or if you're teaching virtually, you want to be prompting students, you want to be probing students, you want to be asking questions to kind of nudge them along. But the goal isn't necessarily that everybody's, a level 4 here in Ontario or an A+, comparing fractions student. It's the beginning of the learning journey. And now you know so much about each of your students, and that can impact like where we go next, both in this lesson and the remainder of the unit.
Yeah. And in these days, the more and more I use our problem-based lessons to teach my students, is the goal, like you just said, Kyle, the goal now is I always think of two goals almost in my lessons. I do have an end goal. I do have a learning goal that I want to bring about. Like maybe it's a particular strategy. Maybe it's a way to, look at a relationship this way. Maybe it's just, maybe we're solving two-step equations. I've been using that example today. But the other goal is, like you said, I want to see what we know first. And that is, that it's almost like 3 birds, 1 stone, Kyle, because I'm going to emerge that learning goal. I'm going to see where my students are, and they were all engaged in learning and thinking instead of just kind of copying stuff down and not thinking. Like, think of all the 3 benefits you get there when you start with a problem-based lesson and you didn't pre-teach everything. Is you get to see where your students are. They are thinking along the way and using prior knowledge or past ideas that they've had, and they're using their brains. They're communicating with each other, and you get to bring out that learning goal at the end of the lesson.
Yeah, I love it. And thinking beyond as well, as we kind of roll, we've talked a little bit, like the last thing we wanted to talk about is this idea that, a problem-based lesson, it's not a standalone, right? If it is a standalone, then you sort of lose some of that benefit you just referenced, John. Like
Yeah.
if I look at it as just something I plop in there randomly, I don't think you're going to get that same benefit. But I want to go back to like, think this woolly worm scenario. So this particular educator who's fantastic educator, constantly reflecting on their practice, they try this, and then now it's like, okay, I've got my next steps for my consolidation on what I really want to spend the time on. So think of how I used to teach, and the way you used to teach, John, was like, today I'm going to talk about this, and this, even though I have no idea whether everybody knows it or whether they're ready for it, or, that might be a little far-fetched. I know somewhat where students are, but if it's a brand new concept, there could be like 3 of these 5 things might be something students are like pretty strong with. And I can spend more time on these 2. So this teacher now goes, okay, this is what I need to spend some time on in the consolidation. The reality though, is in that class and in this particular teacher's response to us, they said, I had some students that were successful, and then I had some students who were kind of stuck. So it's like, okay, you've got to pick some of that student work to help kind of bridge that gap and show the connections. But then guess what? I can give them a consolidation prompt for for tonight, let's say, like one question just to kind of get them thinking. It might be 2 different questions, one for, some of these students who are comfortable with representing those fractions. So maybe it's more on comparing. And maybe for this group, it's more on like, hey, we need practice partitioning our wholes so that you can make 6ths and 8ths and 5ths and some of these other ones that students were struggling with this particular teacher. But then the next day doesn't necessarily have to be a brand new lesson. It doesn't have to be a new problem-based lesson. It might be what we call, like on day 2 of many of our units, is usually a purposeful practice day. We usually start with a mini lesson of some type, which is essentially like we'll build on the previous day's concept, or context, usually just verbally. So we just say the context. We give them an opportunity to reiterate the idea that we were trying to draw out, give students the opportunity to build fluency and flexibility with this idea. It allows me to then kind of go, okay, yesterday I had these students who were really, feeling good. These students who are struggling, where am I now at the end of this math talk, at the end of this mini lesson that we're going to do here as a group? And then I can send them off to do some practice problems, which, surprise, they're not necessarily engaging because it's practice. I don't need to engage them for practice. It's like, no, now it's like, now know what it is we're after. Let's now work on this. And maybe I can pull a small group, or I can, make an excuse to go talk to these 3 students so that I can address specifically something that they missed. But really, it's like we're building off the problem-based lesson to do the deeper learning and to really, you can call it remediate in some cases, but it's like, push students further and accelerate their learning, whether they got it yesterday, push them to the next point, or whether they were struggling with that idea, give them an opportunity to try to accelerate their thinking as well. It's not disconnected. And it wasn't like one and done, and then tomorrow, we start teaching them something to get them ready for the next problem-based lesson. It's like, no, we're going to practice. We're going to get better at what we did yesterday. And hey, I'm going to even challenge you. Yesterday, I saw this model, or I saw this strategy. I wonder, how about in this scenario? I want to challenge you to try this strategy if you didn't try it yesterday, or try that strategy if you didn't try it yesterday. So everyone has something to work towards, and we're seeing this progress. And when students see that fluency and flexibility start to build, their confidence starts to rise. And then they become more brave. They become more vulnerable to actually like stick their head out a little bit, or stick their neck out and go, I'm actually going to engage in this problem, because they weren't expected to know the best way to solve the problem in the first place.
Yeah, that's a great point. And I did want to bring that up about the confidence students do get when they are continually being asked to think first, and then you're responding to them. So that's such a great confidence booster when we teach this. So another added benefit here, which is what we're trying to do, right? We're trying to get students to be confident, to be fluent in mathematics. And you can't do that doing this way of, leaving the problem-based lesson as a drop in. And so, Kyle, you've said it before that we're trying to build our lesson and build our unit around a problem-based lesson instead of fit that problem-based lesson into our unit. It's a kind of a backwards kind of approach here than the traditional, our traditional approach to fitting in these tougher problems. As we start with that problem and then we build our unit around that. And just wanted to address something on timing. I know that sometimes we say, and it depends on the time you have with your students, because you said, day 2 might be a math talk and then a purposeful practice. And it depends on how many minutes you have in your math block. It's also possible. It's definitely, and I'm cutting myself off here because it's definitely possible based off the topic that or the problem-based lesson that you're working with, that you, in your first part of your lesson, you do all these things and you consolidate. And then in the second part of your lesson, that could be also a purposeful practice piece, depending on how many minutes you have. Because I know that a lot of times in my class, I can fit both of those pieces into one day with my kids on my math block. So in that particular class. So I think it's such a great thing about building your unit around a problem-based lesson. I know that we've been doing that, right? We have many lessons as in problem-based lessons on our website. However, there are many units built around those lessons. And so we usually have 5-day units or 6-day units or a 4-day unit that kind of take that approach of introducing through the problem-based lesson a purposeful practice, then extending a little bit more into a new kind of extension idea, and then another purposeful practice or math talk. So we've got those full lessons, full units for you to access over at makemathmoments.com/tasks, which is where we house our catalog of units and tasks, lessons for you to use, so that we've had Kyle, last month at the time of this recording, last month we did a full video, a webinar series on transforming your textbook into these types of tasks. And I know that some of the folks were saying, like, we went through the course, we went through that webinar series with you guys live. It was a great experience, but it's sometimes time consuming to think about transforming those lessons. And a lot of times I say, yeah, it is. And we're just super geeks. And that's why we want to do it. And that's why we've built the library, for the folks to use our lessons. If you can fit one in instead of remaking one of yours. But we just wanted to show how we've remade ours in that series. Kyle, let's do a quick recap here. I want to recap the 3 misconceptions we've talked about here. I'm just going to do them in the order we did talk about them. We talked about misconception being the purpose of using a problem-based lesson. We spun that around to say, hey, we're purposely choosing this to introduce ideas, not to kind of practice ideas later. So that this idea of what is the purpose is a common misconception. The second one we talked about here was addressing the idea that many teachers think their lessons are failures because students didn't show them the strategies they thought the lesson was supposed to bring about. We talked about how to think or readjust your thinking around that idea, because you're bringing up to merge ideas, and then there we can connect dots afterwards. And the last one here we just talked about here is this idea of this problem-based lesson being a standalone approach. We want to build our units around that particular lesson and not the other way around.
I love it. And friends, of course, if you are thinking about doing problem-based lessons and you need a little bit of support, of course, reach out to us. We love hearing from friends. Comment on the blog or on the YouTube channel, and we'll do our best to help support. But ultimately, at the end of the day, I would say if you're new on this journey, or maybe you've been on this journey and you're still feeling like it's just not where you want it to be, go and try one of those problem-based units. And I would argue look at the entire unit before you dig in. Just like have a look, kind of
Mhm.
plan. What does it look like? Because, you know, something we didn't mention here, we won't dig into it too much, but some people say, well, you said day 2, does it have to be day 2? And
Right.
it's like, no, of course not. Like, you know, your block is going to be a different time length, and, you know, maybe it might look a little bit different. But what I would suggest though, is try not skipping over things. At least try a unit, try to use like a good amount of each one, especially those math talks, because I'm telling you, those math talks are designed in a way that will help you build that fluency and flexibility. The thing we always say we want our students to have, but yet it seems we never have enough time to do it. And
True.
I think we need to make that time. So I would really encourage you. That's one thing I would say. Go try one and like actually like give it a really good shot. Don't just pluck out the problem-based lessons, because like John said, day 1 and oftentimes day 3, somewhere in the middle of the unit, we'll have another problem-based. You just do those 2, like you're going to be stuck with some of these same misconceptions we chatted about. But hopefully you found this helpful. I know for us, the more we talk about it, the more we kind of organize our thinking and how we might go about teaching the next lesson when we're in the classroom. So we want to thank the Math Moment Maker community for hanging out with us as always. And friends, what are you going to do in order to reflect on what we chatted about here today? A good idea might be to write it down, right? We talked about 3 misconceptions. Go write them down. If you're a sketch noter, get out there and start sketching it down, or go and tweet it, or throw it in our Facebook group, Math Moment Makers K through 12. Whatever you do, make sure that you're doing something so that this time, this investment that you're making to listen to the podcast will pay the highest dividends that you possibly can.
Good tips there. Good tips. In order to ensure you don't miss out on new episodes of this podcast as they come out each week, be sure to subscribe on your favorite podcast platform. Also, don't forget to jump over to YouTube and subscribe to us over there. We are putting also weekly videos out, not necessarily this video that you're listening to right now. We've got new weekly smaller chunked videos on how to do things. We've got a series on how to teach algebra in a visual way. Kyle has a whole playlist on how or classroom sneak peeks. So specifically, you were talking about running, a problem-based lesson and what that might look like. We've got a full sneak peek that Kyle used with a class he taught not long ago, so you can get a sense of what that might look like and sound like. So head on over to YouTube and subscribe over there as well.
Awesome stuff. Show notes and links to resources from this episode, as well as all the other episodes, can be found over on the website. But for today's episode, head over to makemathmoments.com/episode 172. Holy smokes, we've got lots of episodes going here. Again, that's makemathmoments.com/episode 172. Well, until next time, Math Moment Makers, I'm Kyle Pierce.
And I'm John Orr.
High fives for us.
And high five for you.